Hello, this is Mrs. Schaefer, and I wanted to share some helps with you for the 4.05 discussion quiz. You can find this in your course in the chapter 4. So you're clicking on content, then going to the chapter 4. And if you go to the 4.05 lesson, you'll see the lesson material where you'll see these slides. And then you'll see the discussion and practice quiz link. That's where you can preview the quiz before you go in and start to take it. Remember that you can take notes and prepare for this. That's why it's called a discussion quiz. You can use your notes, and then you definitely want to check out and watch this video to help you out. Remember also that your review sheet is there to help you. We have been collecting this information on our review sheet to help us prepare for the assessment and also this activity. We also had that simulation where we built an atom. We talked about what happens when you change the number of electrons, neutrons, and protons, along with calculating the atomic mass and the atomic number. So please go in and review that information before you enter in to take the quiz for the 4.05. I'm going to go through some practice problems with you to help you out with this. So we're going to review some of this material. First question, what is the atomic mass of this element? Well, we can see that in this drawing, all of our parts are labeled. That is pretty common to see P's or pluses for protons, N's or zeros for neutrons, and E or negatives for electrons. Also remember too, that when we practice our build an atom, we really didn't focus too much on the electrons, just if they were stable, an atom was stable or not. If the protons and the electrons matched, then the atom was stable. If they didn't match, it was considered unstable. And we haven't really talked about electrons much yet so far in the course because that information's coming up. The electrons are very important in chemistry because it's part of the chemical properties and the bonding properties. So far, we've really only focused on the protons and the neutrons. So I'm pretty sure the atomic mass is not going to take into account the electrons. Be sure to check out that lesson material because you'll definitely find some good information for you. How do we figure out the atomic mass? What do you think? I hope you chose that you determine atomic mass by adding the protons and the neutrons together. So we have to count up the protons and the neutrons. So I see 1, 2, 3, 4 protons, 1, 2, 3, 4, 5 neutrons. 4 plus 5 is 9. So our best choice is C. All the others are eliminated. Oh, this looks the same. Look, the picture's the same, the answer's the same. There's only one word that's different, and that one word is a number. And that changes the whole answer. This question's asking us what is the atomic number of the element. The past question asked what the atomic mass was. Big difference between those. We get a different answer. Well, it's probably not going to be the answer we asked on the last question, so we can automatically eliminate 9 or option C for our choice. How do we determine the atomic number? Well, if I go back in and check my review sheet, it says that the protons, the number of protons, determine the atomic number. Well, I know from my last question I had 4. I can count them on the screen, so my best choice is 4. The atomic number is 4 because there are 4 protons. Well, this is a new picture. How do we figure this out? We've not seen this picture before. Well, we can figure it out based on the charges because look, these are negatives, these are positives, those are zeros. Oh, okay. So protons have a positive charge, electrons have a negative charge, and the neutrons have zero charge or a neutral charge. So we can figure that out just by counting up the positive charges, the negative charges, and the neutral charges. Then I need to figure out the atomic number and the atomic mass. I'll be using my last two questions to help me answer this question. Well, this is something a little bit unfamiliar too. I haven't seen a strip and I don't know what AR means and SI means, or GE means. You haven't taught that to us. That's okay because I have taught you everything else. So you can ignore the element name for argon, silicon, and I actually don't even know GE. I'd have to look it up myself in the periodic table. But the question asks us which is the correct symbol. So which one of these is correct? This is basically going to be a math problem. Which one has 18 protons and 14 neutrons? So I have a strip of the symbols all figured out. I'm going to use this in the corner to help me because this is in my review sheet, or should be. So the atomic mass is figured out and labeled at the top left of my element, and the atomic number is down here on the bottom left. So all I have to do is figure out which one is correct and which one I can eliminate to show which symbol is drawn correctly. Is it A? Is it B? Is it C or D? That will show me the atomic mass, the correct atomic mass number, and the correct atomic number for 18 protons and 14 neutrons. So I'm still using that information. How do I calculate atomic number? How do I calculate atomic mass? Okay, so carbon 12 and carbon 14. What are these called? Why is it called carbon 12 and carbon 14? Well, I can see that there are 6 protons and 6 neutrons in carbon 12. That might help me out. Carbon 14 has 6 protons and 8 neutrons. So there's a name for atoms that have different number of neutrons. If it has a different number of protons, it's a different element, because we know that the number of protons determines the type of element it is. But when we change the neutrons, what is that called? And then here we see percent, 98.9%, and then less than 0.1%. So if we gathered up, what that means is if we gathered up all of the carbon that's present in our world, 98.9% of that carbon will be carbon 12. And then what's not carbon 12 will be carbon 14. That's called the percent abundance. We talked about that in a previous lesson. So the percent abundance. Now let's look at a different situation. I have 4 different types or symbols here. Sulfur 32, 33, 34, and 36. What are these called? How are each of them different? I see a 32 here, a 33, a 34, a 36, just matching up here. I see this, it says they're all stable. And then I see the percent abundance. And this is their actual calculated weight, but you'll see they rounded to help that. All right, so what does that 32 mean? How is that going to help us out? What makes these different? They have the same symbol. In fact, I can go to the next screen and see my S symbol right there. It's sulfur. And, oh, that number's there matches 32.06. And it says 16 is the number. And if I ever forget, most tables have a key. So I see the atomic number, I see the element name, the symbol, and then these other things we'll learn more about it, but then it will talk about the relative atomic mass, which is the average of everything. So when I come back here, I know that sulfur has 16 protons. Here's a question for you then. Which of the following isotopes would have the greatest number of protons? Is it A, B, C, D, meaning none, they all have the same number, or E, still thinking about it? And this is going to go to that essay question, which we're going to look at in just a second. And then, are the electrons different? So this named this an isotope 32, so sulfur 32, sulfur 33, sulfur 34, sulfur 36. Hopefully you picked D, none. They all have the same number, because if they have a different number of protons, they would not be sulfur. Okay, so let's look at this essay question. This is worth 4 points. There are 3 stable atoms of argon, argon 36, 38, and 40. What would the atoms of these isotopes have in common? What do they have in common? And what do they have different? Explain your answer. To help you out, here are some hints. Count up the protons. Determine how many protons there are. Then determine how many electrons there are. The protons and the electrons will equal each other because it's stable. How about how many neutrons are there? Well, to determine that, we're going to have to go back in to our periodic table and find argon, which is right here. Argon is right there. So I can see that it says the atomic number is 18 and it has that mass. Well, let's go back over here. All right, so I have 18 protons. That means I'll have 18 electrons. How many neutrons will I have in argon 36, 38, and 40? Tell me, why do we call these isotopes? Be very specific. Explain the 2 things they have in common and what they don't have in common. I hope that helps. If you have any questions or concerns, please let me know.